Lecture 7.6, the number of fringes in an interference pattern. To determine the number of bright and dark fringes, one must, in some form, calculate the value of M, MC, MD. One way is to use the path difference equation. In fact, you can only use the path difference equation, but there's two ways to do it. So one way to do it is that when you deal with the path difference equation and you solve for sine of theta. And what we're going to see here is that when you solve for sine of theta, this will be directly proportional to M. So if you look at this, I have constructive interference. That means that this path difference is then going to be d sine of theta, which is then MC lambda. Right away, you see here is that if you solve for sine of theta, you get this quantity lambda divided by d by MC, and you could see that it's directly proportional to MC. I can say the same thing for destructive interference. Here, our path difference equation is directly proportional to MD in this combination. So if I solve for this, you're going to see here that I'm going to get MD, lambda over D times the quantity MD plus 1/2, which is again proportional to MD. So we can determine the M value by looking at the sign. So how do we do this? We take advantage that the sine function only makes mathematical sense if sine of theta is, less than or equal to 1. On the other hand, sine of theta greater than 1 is nonsense. So what we're going to do here is that we want to use the sine function and run a sequence until we violate sine of theta greater than 1. So to determine the value of M, that is the number of bright and dark fringes, we will sum a sequence of m values until sine of theta is greater than 1. This immediately stops the sequence. And that I need to really put a little bit more time in showing you what I mean by that. But one of the things that's important here is that you can see that there is this term lambda over d. So a key parameter for this sequence is what Carlos calls the interference parameter. So if you were to Google this, you wouldn't find anything. But the interference parameter is defined as d over lambda. And it turns out that d over lambda, which is directly proportional that's not right, to the m value. In other words, d over lambda is proportional to m. Now, what's nice about this here, by calculating this quantity, you immediately start to understand how the interference pattern is going to look like. So, for example, if I have a large interference parameter, and in this case, we'll say, hey, that this value of d over lambda is large, then what it tells us is that there are more fringes. And if there's more fringes, then we have a large m value. So in other words, let's say that here's my interference patterns. You know what? Let me just copy these. So if I copy these just to be faster, what I'm so let's say that I create interference patterns that look like this. So I'd say that's a lot. Now, if I have a small interference parameter, in this case, let's call it d over lambda, then I'm going to have a small value of, I'm going to have less fringes, and therefore I'm going to have a small m value. So if I now, let's say I look at this guy here, and let's say that this is what the fringe pattern looks like. So if I now look at this, what you're seeing here is that I don't have as many fringes. So that's what that parameter is telling you. So what I'm going to do now is that I'm going to go through the details of the sequence so you can see what I'm talking about. And then we'll use an applet to back it up. So here we go. Let's go through some examples. I'll go through 2 examples. This is example 1. And what I'm going to do here is that here I'm going to set d equals to 3 lambda. Okay. So in other words, what I want to do here is that I want to determine the number of fringes when d is equal to 3 lambda. So now I'm going to say here, so now I'm going to look at, I'm going to start with the path difference equation. And we said here is that if I manipulate this, this is going to be sine of theta of lambda over d of mc, but this is the same as 1/3 mc. And so now what I'm going to look at is that what I want to do here is I want to come in here and I want to now start putting in my values of mc till sine of theta is greater than 1. So in other words, we now sum the sequence by inputting the m value until sine of theta is greater than 1. Once that's the case, then this tells us what the maximum value of m is. So let's go do that. So now, here we go. So now I'm going to sum the sequence. So I'm going to say this is sine of theta, and then I'm going to have 1/3. The first value is 0. That's less than 1. Okay, so that works. Then I go 1/3 times, then of course I get plus or minus 1. That's 1/3, which is less. And then if I keep going, you could see here that I'm going to get 1/3 times plus or minus 2. That's 2/3. And then I'm going to get 1/3 times plus or minus 3. Now, note that's 1 right there. But to look at the sequence, this is 1/3 times plus or minus 4. You could see that now that violates. So if I now start looking at the values, this is 0. This is plus or minus 1/3. This is plus or minus 2/3. This is plus or minus 3/3. And then this guy is plus or minus 4/3. So right away, you see here that the sequence stops right here. So what we're saying here is that this is not possible. And the reason why here is that the sine of theta is now greater than 1, which now stops the sequence. So this implies here that I now know that MC now has a value of 3. Has a value of 3. Okay, so that tells me then, if I start to look at what you're seeing right here, if you're just looking at these numbers, what do we see here? So the number of bright fringes are the possible values. That's what I'm talking about. These values right here shown above. So here we go. So when I look at the number of bright fringes, we see that there's the 0, right? So this guy, this occurs because we have MC equal to 0. That's the central max. Then note that each of these values has 2 because of the plus and minus sign. And so this guy tells us because we have a plus and minus sign, I have to double count them. And then I see that the sequence then goes all the way to MC. So in this case, this is going to be 1 plus 2 times 3, which then tells us that there's 7 bright fringes. That's how I look at that sequence. Now I can do the exact same thing for the dark fringes. So let's look at the dark fringes. So again, once again, we start with the path difference equation. And we follow the same process as we did with constructive. So what I'm seeing here is that I know that I'm going to have sine of theta. This is going to be lambda over d times md plus 1/2. And we know that this will be 1/3 times the quantity md plus 1/2. And again, we know that md is going to be 0. Then we get plus or minus 1, plus or minus 2, etc. Okay? So here we go. So I'm going to follow the same procedure as above with constructive. So here I go. So I'm going to have sine of theta is going to be md plus 1/2 divided by 3. So I get plus or minus, and I'm going to get 0 plus 1/2 divided by 3. So immediately what you're seeing here is that the way I would write this to get a sense of what I'm looking at, I would write this as 0.5 divided by 3, like this. And then I continue. So then I keep summing. I'm going to get plus or minus. Then I'm going to have 1 plus 1/2 divided by 3. So then this tells me that this is then going to be 1.5 divided by 3. And you can see here that this is less than 1. So I keep following my sequence. And then I go to 2 plus 1/2 divided by 3. And you could see here is that now I'm at 2.5 divided by 3. That's still less than 1. And now when we get to 3 here, I get 3 plus 1/2 divided by 3. And you can see here is that now I get 3.5 divided by 3. And you can clearly see that this guy now has exceeded sine of theta greater to 1. So then this tells me here is that the maximum value now of MD only goes to 2. So remember, this guy is telling us how many values there are, how many dark fringes. So again, look what I said up here. The number of dark fringes are the possible values shown above. So it's the exact same thing. In fact, I'm going to copy this to show you that it's exactly the same. So now if I come in and paste this, so instead of bright fringes, these are dark fringes, right? These are the dark fringes. So when I'm looking at this thing, what are the possible values? Here are the possible values. So then we go, the number of dark fringes looks like this. So note, there are 2 zeros. Okay, so I'm going to write 2 here, and this is because there are 2 zeros. That's what I've been calling plus or minus. And then, because of the plus or minus, note that I'm always going to have a value of 2. Again, that's because the plus and minus. And then this guy is going to be times MD. So then if I put this together, I'm going to get 2 plus 2 times 2. That gives me 6 dark fringes. So now what we want to do here is we want to sketch out the pattern. Okay. So let's sketch out the pattern. So, but there's some important details to look at. So there are some important details to remember. The first thing that you want to look at is that the interference parameter how do I say that? The interference okay, I'm not liking my English. Let me move this over a little bit. I'm going to say this. So if the interference parameter d over lambda is an integer, then the last fringe is a bright one. 2, if the interference parameter is a half integer, then the last fringe is a dark one. So those are really, before we get into our situation where we have partial fringes, we want to start off with the easiest possible cases here. So here we go. So in our case, In example 1, we have d over lambda, which is exactly 3. So this immediately tells us that there's a bright fringe at 90 degrees, which means that it's the end of the pattern. So here we go. We know that we have 7 brights, right? We know that we have 7 brights, and we know that we have 6 darks. So let's start drawing these out. So what I'm going to do here is that I'm going to try to center this. So let's say I do here. Okay. And I'm going to draw 2 patterns. I'm going to draw an intensity profile, and then I'm going to draw an interference pattern. So I'm going to say that this is 0 degrees right here. And since I don't know how I'm going to draw these, I'm going to try to make these somewhat fast here. So let's see here. I'm going to try to draw these symmetrically. So let's say that I have this right here. So I need to start counting here. So I have 7 bright spots. So I'm going to copy this, and I'm just going to start just inserting them. Nope, that's not what I want. Okay. My machine is slowing down. So here we go. Here's my pattern. So I'm going to say that they're typically equally spaced. So that means I'm going to have 3 on each side. But the very last one is going to be different, as you'll see. So what you're seeing here is that I have, right now I have what? I have 5, but I need 7. So this last fringe is going to be different here because it has to end at 90 degrees. So I'm going to attempt to draw this. So it's going to come like right here. And what you're seeing here, that this is at 90 degrees, this fringe. Now, what you're looking at here is you're looking at something like this here. Note that this is not the same as the others. And the reason why it's not the same here is that there's the small angle approximation is not valid anymore. So they're not going to be evenly spaced. So I got to do the same thing with the other one here. And then again, here's my 90 degrees. And what I'm really plotting here, this is I relative. This is what's called the intensity profile. Now the fringes, the interference pattern is different. So the way I look at the interference pattern here is that I'm going to start to draw these squares. And they should be symmetric. Of course, they're not. So then if I look at my interference pattern, you're seeing that I have a sequence of bright as well as dark fringes. So let me move this up and then let's label these. So from our pattern, from the sequence that we just did, we have an MC value and we have an MD value. So when I look at MC, here's my 0, then I get +1, +2, +3, -1, -2, -3. Then I get my darks here. I have 2 zeros. So look at it. I'm going to do something strange again. I put that minus sign in the 0 because that minus sign just tells me that that's the 0 to the left of the central max line. Then I get -1, -2. This will be +1, +2. And that's the sequence. There's nothing more. And by the way, if this was on a flat screen, -90 degrees is infinitely far away from the central line, right? So right here, if it's a flat screen, it's at 90 degrees. So it has to be infinitely far away. Now, what I want to do here is to show you this pattern. I want to look at an applet. So I'm going to look at the wave interference. Number 1 applet. This is such a good applet. It's one of my favorites in all of physics. So what we want to do here is that we want to set this d over lambda equal to 3 and check our work that we just did. So let's go look at that. So here is the applet, and what you're seeing here is that they tell you this is wavelength. They tell you that this is the separation, and you could see that the diffraction, the interference parameter right now is labeled as d over lambda equal to 3.65. We got 3, so I'm going to have to change this to try to get a value of 3. So if I make my wavelength longer, that's 314. Let's see if I can. Oh, look at that, 3.0. Nice. So now you could see I'm going to copy this pattern, okay, and put it on my screen here. So that is perfect. Okay, so let me grab that and let's go put it in. Let me do a new share. And so here's what we're seeing right here. Here's my pattern. And so what we want to do here is that the first thing that you want to look at is that note that this is not a flat screen that you're looking at. In fact, it's a curved screen. So what I imagine here is we have something like this. I imagine that we have a curved screen. I'm not sure how to draw a curved screen here, but I imagine that it's going to look something like this here. I'm going to go around. Let's say that it does that. And then I need to do my screen. And then this guy has to come around. And then what you're going to see here is that this guy now comes something like this. And this guy's sort of like wrapping around that thing. So if I was to look at the screen, here's my screen. And you could see here that it's curved, not flat. Otherwise, you'd be looking at an interference pattern at infinity. Now what I have here is that now I have my two slits that are going to be doing something like this here. So my sides are going to look like this. And if I look at this, now I have my two slits. Oops. There's my two slits right here. And now what I'm shining here is that I'm shining my laser. And now you're starting to see the interference pattern here. So in this case, we saw that it goes straight. So there's going to be 1, 2, 3, and then there's one at 90 degrees right there. And I can do the same thing here. And that pattern has to look like this. So what I'm seeing on my screen here is that you can see that now I could go in and label these guys. This guy right here is MC equals to 0. Note that there are 2 1s. So this should be MC equal to +1, and this has to be MC equal to -1. Then down here, I have MC equal to -2, and this guy is MC equal to +2. But look at the edges here. What the edges show here is that this has to be MC equals to +3, and this is MC equal to -3. But you can see at the end, look at the width of these guys. So if you look at the first 3 widths, note that they're the same size. But as I get further away and I start to violate the small angle approximation, MC2 and 3 are not the same as the other ones. Now, if I go and I look at my darks here, the darks are the blurred, so this has to be MC, look at that, -0, MC +0. Remember, we're just using the plus and minus signs on the 0 to mean, am I going to the right, in this case, up or down from the central max? Then you could see here, I got MD equals to +1. This is MD equal to -1. Excuse me. And then finally, this is going to be MD equal to +2, and this will be MD equal to -2. So we're getting these interference patterns. Now, one of the things that I sometimes do is that you can draw an interference pattern, a slightly different way. So if I look at my interference pattern, I could say that by hand, I could then, here, I'm going to move the distance here. So I'm going to come here, and you could see that this guy is getting broader. And then I have another one. I'm drawing it too wide. So let me try again. So I'm going to have a pattern that looks like this. Then I have to stick in another one right here. And then another one here. So what do I have? I have 1, 2. I need one more. Ooh. Then there's going to be one at 90 degrees, and then there's going to be one right here. So then if I look at my darks here, you could see so half the pattern looks something like this here. So then here's my interference pattern, which is the image that you're just seeing right here. That's not my preferred way to draw this pattern. My preferred way to draw them is with the intensity profile, because that's mathematical. And this is what you see in the lab situation. Okay, so now let's go to another example. So in this example, we're going to look at something slightly different. I'm now going to set D equal to 1.5 lambda. So the other one was an integer. This guy is a half integer, which then tells me if it's a half integer, that I must have a dark fringe at the very end. Integers give you brights, half integers give you darks. Okay, so here we go. So what we're doing here is that the interference parameter is D over lambda in this case, which is 1.5, versus in example 1, it was D over lambda equals to 3. In other words, this guy should have what? This has more fringes, and this guy has less fringes because the value is smaller. So let's go look at this. Let's go calculate this quickly here. So we're going to do this a little bit faster now. So now let's go look at the bright fringes. So I'm going to go through the sequence here. So I'm going to have sine of theta, which is lambda over d, mc. So this value is mc divided by 1.5. So here we go. Now let's follow the sequence. So then I'm going to get 1.5, 0. Then I'm going to get 1.5, 1. Remember, plus or minus 1. Then I'm going to get 1.5 over the sequence of plus 1, 2. And right away, you can see here that this now violates sine of theta greater to 1. So this tells me here that my MC value has a maximum value of 1. So now, if I look at the number of bright fringes, we say here that we get 1 plus 2 MC. Remember, the 1 is for the 0, the 2 is for the plus or minus, so then this equals 1 plus 2 times 1, which then gives me 3 bright fringes. So now I have my bright fringes. Let's go to the dark. If I go to the dark fringes, Then it reads, following the same process, it's going to be sine of theta. And this is going to be lambda d times md plus 1/2. So this is then going to be md plus 1/2 divided by 1.5. So here's my sequence. So if I start my sequence, it's going to be, I'm going to get 0. But remember, there's 2 zeros, so I have to put plus or minus. Plus 1/2 divided by 1.5. Okay. That's less than 1. Then I keep going. So then I'm going to go 1 plus 1/2 divided by 1.5. That's 1.5 divided by 1.5. So that right there is 1. But to keep going on the sequence, you can see here is that now I have 2.5 divided by 1.5. Right away, this tells me that now it exceeds sine of theta greater to 1. So when I look at this, then I see here is that my max value of d, md that is 1. So now if I look at the number of dark fringes, this is going to be 2 because of the 2 zeros. Then this is going to be 2 because I get plus and minus. And then it's the MD value. So then you can see here that I'm going to get 2 times plus 2 times 1. I get 4 dark fringes. So one of the things that you should note, which I did not note last time, look at this. These have the same value, and they always have the same value. And I want to go through this long process of calculating because then it's going to be easier to when we actually get to the mathematics. So now let's go look at what we did before. Okay. So now what I'm going to do, just like I did last time, I want to plot the interference pattern and the intensity profile. So let's go look at this. So now what I'm going to do here is that I'm going to plot this pattern. So it's going to look something like this here. So I'm going to try to scale it as we did before. So I think I did 10 squares. So let me try to do that again to try to do that. And I think the peak intensity was about 2 squares. So then I'm going to go. So here's 10 squares. Well, almost. And I need 3, 4, 5. So that's my 90-degree point right there. So these guys are going to look something like this here. So I'm going to try to, these are not going to be symmetric either. So I'm going to try to keep these to 2 squares, a little over 2 squares, I think is what I did this one. So these have to be fatter. So there's one, and then I only have one more bright fringe. So then, because of the small angle approximation being violated, this guy has to be wider. Now note, this line right here is my 90-degree line. Note that this does not go all the way to 90 degrees. So let me try to be symmetric here. So this guy has to end right here because this is my 90-degree line. So then if I look at this, it should be symmetric right here, but then it dies off right there. So if I look at my pattern looks something like this. So now that I have my pattern, you can see here that this guy is my intensity profile. Now I want my interference pattern. So what I'm going to see here is that as I draw my first one, then my second one goes to here. And that's it. Then I have my dark fringes, and you could see that at 90 degrees, it's dark. So now I could then come in and put my MC values. So here's MC, and then here's MD. So if I put them in, this guy's going to be 0. This will be -1 plus 2. That tells me my 3 fringes. Now for the dark fringes, here's my -0, my -1, my +0, my +1. That's my pattern. So now let's go check this with the applet. So let me go share my screen. And here we go. So now what I need to do here is that I need to get this to 1.5. Nope, I need to increase this. Okay. Oh, 1.5, that's perfect. So you could see here is that if you look at 90 degrees, note that that's 0, right? That's 0. So that's exactly what we would have expected here. Now, I just did a screenshot, so let me go and put this back into my OneNote. So if I paste this, look what we're seeing. It's exactly what we would have expected here. So if I now go and I look at my sequence here, you can see here that this is MC equals to 0. This is MC equal to +1. And then this guy is MC equal to -1. And if I start to label my darks here, this is MD equal to -0, MD equal to +0. And then at the very end, you'll see here that this is 1 in both of these cases here. And so it matches up exactly what we expected.